Okay, and hi and welcome to the Design II video retrospectives for week 4. First, we'll start off talking about design. One of the things we talked about this past week was the design binders. We'll be grading those for the first time in this upcoming week, week 5. This binder should basically be everything about your design. If we look at your design and we have a question about the process or a certain aspect of it, looking at the binder should give us a good idea of where that came from. So this kind of replaces the appendix in your submission 3 as well as later reports, which we've had in the past. So it should have a good breadth of material from calculations, justifications. Those calculations should be, checked by other people, nice, clear material, articles of research, your past submissions. If you're basing your wind turbine design on another one and you have done some good research about it, include that research in the design binder. It's really a free-form document for you to assemble everything that a person should know about your design. The second other thing that we're really pushing about the design binder is structure. So we're looking for something that's organized, table of contents, or some easy way to navigate it. If we just get a binder full of papers, that's completely disorganized, that's really not going to help us, and it's not going to help you in using that document. So we'll be grading those. Either we need a hard copy, or we've said that you can have some sort of digital design binder as long as it's well structured and you're able to give it to us somehow at the beginning of lab. Either pull it up on a computer or tell us how to pull it up, or give us a CD or something. The other thing we talked about was submission 3. So submission 3 is not due next week, this coming week, but it's due the week after, so week 6. And what we wanted to really reinforce is that for submission 3, you're going to be working with real numbers. So we're not looking for your criteria to be graded, like out of 10, which would be real numbers, like 7 out of 10 for moving pennies. No, what we're looking for is like how many pennies are you going to move? How many dollars of material are you going to have in your devices? So we can understand that can be kind of daunting. Coming up with real numbers can be really challenging. So what we suggested was just kind of start with something, get your calculations going, get a number, and then start to try and refine that process. So say you were, getting a number for how much energy your wind turbine is going to output. Well, if you set up the calculations, put a whole bunch of numbers in there, and look at it and go, wow, so, that outcome, we've got the calculation flow, but it's giving us a really high number, and we've assumed that we're getting 59% of our efficiency on the wind turbine, which is Bet's limit. That's probably not true. So how can we refine that number? Maybe you based your wind turbine off of a commercial model. Look at what efficiencies those get. You're not going to get that efficiency. Make an intelligent judgment on, a factor of safety, so that you can probably get an efficiency that's more along the lines of something that you could expect. Because looking for the perfect numbers right from the start, you'll get lost. You could spend a week looking for a certain value that you need for your calculations, just to realize that once you throw it in, a change of 500% in that value only changes your final result by 2%. So it's better to kind of get it all laid out, start working on those calcs, and then refine the worst assumptions one by one. Besides that, we just wanted to also say that you can have hybrid designs. So if you look at your 3 designs, you do the calcs for all 3, and you say, a combination of the wind from A and the penny moving system from C would be the best. You can make a new system out of that, give us the stats, and then talk about that in your discussion. In terms of the CAE project, 2Ds are due this coming week. We said in lab that we take it back. You don't need a cover page. Having a cover page for a 1-page document is not necessary. And with that submission, we need your database. So Warren has put online a document with all of your different parts that you submitted, like that database that you submitted. You need to download the sheet with your parts on it and indicate whether there's no change, whether there's a small change that you're going to write on that sheet and hand in to me, or whether there's a big change, and there'll be places to check these off, at which point you'll resubmit a digital copy of your database to Warren. So regardless of the 3 choices that you make, you need to print it off, check those boxes, and give that back to us at the beginning of lab. A few reminders for the 2D. Make sure it's in millimeters. Use a third angle projection. That's what we use in North America. check your drawing against the rules. Once you've got something that you think is good, go through the rules one by one and just make sure that it's conforming. Remember, we're looking for 10 to 15 dimensions. It's a really simple part. In lab, when people would show me their parts, they'd be blown away at how simple a part had to be to really conform. We're not looking for a part that looks exactly like your part. We're looking for something that we can evaluate your 2D dimensioning and layout and drawing skills. It has nothing to do with faithfully representing that part that you're basing it on. A couple other little pointers: no hidden or center lines on your isometric view, and talk to your peers. They can help. A lot of people have probably, for example, if you can't figure out how to get center lines off of your isometric view, I'm sure somebody that you know has. So asking them can get you a long way instead of struggling through on your own. Besides that, just wanted to remind you to get started on your 3Ds, get started early. There's CAST tutorials. They're there to help you, so start thinking about how you would make your part, and if you're thinking of using some more advanced features like we've been showing in the presentation in the past week, start to look through the CAST tutorials for how those work and get those started. But try and figure out the best way. If you think that your part could take advantage of a shell, then try and figure out how that works before you start it a different way, because if you realize that you do need a shell, restarting will be complicated. Just like if you need to start, if your part's made of sheet metal, you might want to explore the sheet metal function. You could build it all yourself with regular extrudes and edge blends, that sort of thing, but using the sheet metal tool might end up being easier and save you a lot of time and make a better looking part. So I think that's it for this week. I'll see you all for week 5. Please have your design binders ready, and good luck with design this week.